This is an interesting article. I like it because the topic is, we want to understand all these climate impacts we are having. What does it do to us in terms, we are ambitious species. We always want to grow bigger, think bigger, go to Mars, occupy the whole globe and exploit everything everywhere. So, what can we learn from past history of humanity and how they responded to and dealt with disturbances, obviously climate disturbances, but also others. Now you have many disturbances. So this is an article that is a meta study with some modeling that looks at this issue and says that frequent disturbances enhanced the resilience of past human population. Is that good news? Well, obviously there are some who will survive and become more resilient, but some will get hammered and buried, and so you have to worry about poor people who are paying a price now for the climate change that's been created mostly by the rich. The record of past human adaptations provides crucial lessons for guiding responses to crises in the future. To date, there have been no systematic global comparisons of humans' ability to absorb and recover from disturbances through time. Here, we synthesized resilience across a broad sample of prehistoric population time frequency data spanning 30,000 years of human history, so goes into the end of the last ice age where we get good data. I chopped off the text a little bit here. Cross-sectional and longitudinal analysis of population declines show that frequent disturbances enhance a population's capacity to resist and recover from later downturns if we survive. Land use patterns are important mediators of the strength of this positive association. Farming and herding societies are more vulnerable but also more resilient overall. More vulnerable but more resilient. The results show that important trade-offs exist when adopting new and alternative land use strategies. So there is that lesson you can get from this past human experiences as documented in the evidence. Of course, you also want to think about what resilience in this context means. Understanding the range of past responses of human societies to disturbances is a global priority across the social and natural sciences and will support the development of solutions to future crises. Numerous case studies have addressed past cultural collapse, transformation, and persistence, although how to best characterize these processes is a subject for debate. A major unresolved issue is the lack of comparability, however you want to say, between cases of population resilience in the historical sciences. Few studies explicitly model impacts, recovery, and adaptation, or formally account for long-term history, which contains important and previously overlooked variations within and between cultural or environmental settings. Furthermore, a tendency to narrowly focus on responses to extreme events in both natural and social systems may overemphasize local or short-term adaptive success at the expense of understanding large-scale or long-term vulnerabilities. A well-known example is the shift to a narrow marine diet among the Greenland Norse that initially offset the short-term risk of crop failure, yet heightened society's vulnerability to longer-term North Atlantic cooling. So you may find some quick solution, but you don't know what's happening in the longer term, then you may be just walking into a trap. Here we establish a global comparative approach to long-term resilience to identify the factors that structure the response of prehistoric populations to disturbances through time. The approach measures population capacity to withstand changes as well as the rate of recovery following a disturbance through the common proxy of radiocarbon time frequency data. Nice detective work. Disturbances are the inferred drivers of relative reductions in population or archaeological activity in prehistory, which are described variously as recessions, downturns, busts, negative deviations, or similar, and form the focus of this study using summed probability distributions of calibrated radiocarbon dates. Very technical work, some modeling which is also very technical. Summed probability distribution functions as an index of relative levels of human activity or population change over time, right? So, the way I read it, you didn't see a verb there. SPDs function as an index of relative levels of human activity or population change over time. So, function is the verb. Population downturns are defined as periods when SPDs are significantly below expected growth trajectories in response to disturbances. Our efforts focus on two key questions. How quickly do past populations recover after downturns? And what factors mediate past resistance and resilience to downturns? So people look at this more formally as whether it's a V-shaped recovery or U-shaped recovery and so on and so forth. Resilience, okay, I won't get into details, but I've discussed it elsewhere. This is a map and summaries of all world regions and disturbance types included. So you have the Yukon with some period ranging from 14,100 to 500 calendar years BP. They use carbon dating. Utah, Wyoming, highland and coastal Peru, tropical lowlands, Caribbean archipelago, Italy, Sicily, Sardinia, circumpolar Norway, southeastern Norway, Greece, Near East, China and Central Plains, Korean Peninsula, and the dates are all different. I'm not going to read off all of them. So there's a fairly representative coverage of the populations, so that it's representative of the different types of perturbations as well. So it shows the relative population over time, so you have to be careful about, here. So the color coding for environmental, cultural and mixed perturbations or disturbances as they call it. Expected growth trajectory of 95% interval is shown in gray. So just schematically, downturn A, rapid pace and long duration. This one is slow pace and short duration. So you can think of it as extreme events that last for a long time and chronic changes that last for a relatively short time. Just classification wise. High relative fall and then recovery, so low relative rise, and you don't, just look at this, low relative fall here and high relative rise. So depends on the type of disturbance, obviously. And here, of course, you have various evidences used to infer aridity, cooling, extreme events, variability. Includes volcanic ash, paleo tsunami records, plant micro and macro fossils, and so on. Culturally, social reorganization, mobility and colonialism. So you have historical and archaeological records, settlement structure, hierarchy, material culture, social network, technology, warfare, all those good things that we did as we evolved over the last 30,000 years. Mixed, so carrying capacity and combinations. Settlement, consolidation or abandonment, subsistence change to florent crops, boom or bust cycles, and shifts in resource diversity. That was the carrying capacity measure. Combinations, intersecting or compounding vulnerabilities, combinations of the above. Okay, so here is a table that's talking about metrics and model parameters extracted from global case studies of past population downturns. Obviously, I won't read all the details, but you have overall duration, cumulative number of downturns in a region, time to minimum, time start, time end, baseline SPD value. Independently, you have resistance, resilience, so nice definitions that are very quantitative based on these parameters. Dependent, so independent and dependent, geographical information, relative pace, frequency of downturns, category, type, land use and change. So land use turns out to be a key parameter in how disturbances translate to resistance or resilience among the populations. Okay, wrong type of land use at the wrong time obviously would make you vulnerable. To read off a few things, global variation variations in recovery rate. Initial modeling indicates that the geographical location of downturns does not affect resistance. with the exceptions of significantly higher values in the Caribbean archipelago and Italian peninsula. So you have to understand why there isn't a geographical location in the resistance to downturns. Is it just the intrinsic evolutionary quality of humans, innovation, social network that did transfer technology somehow, and so on, right? So all those are not very easy to infer, but modeling provides you some insights. Owing to the observed range of variation and its potential impacts on the metrics, study region was retained as a random effect variable in the mixed effect model. So some detailed modeling there. Long-term downturns are the norm, but this will depend on the time period you are considering. If you consider 30,000 years, you are still heading towards the glacial maximum, which happened around 21,000 years, and then you came out of it. Then you had many ups and downs, older Dryas, younger Dryas coming into the Holocene, and so on. And then you became agriculturalists and population began to grow, conflicts, hierarchy, urbanization, etc., military, etc. The duration of population downturns tend towards centennial, so 100 to 500 years, and decadal periods less than or equal to 50 years, with a median of 98 years across the sample. You have to be careful because these are inferred indirectly based on various archaeological and other evidences. Downturns lasting longer than 500 years are a minority. The time taken to reach the summative probability distribution minima skews further towards decadal timescales. So there are statistical details on what happened. So you are looking now here at the summaries of downturn numerical metrics showing the relationship between resistance, resilience, and the duration of relative pace of downturns. So here you are looking at resistance as a category of perturbation or disturbance, cultural, environmental, so the larger range, mixed, and unclear. So there are times when it's not clear what was the actual category of the disturbance, but resistance is not heavily affected by anything. And if you look at resilience, again, cultural, environmental, mixed, and unclear. So overall duration and time to SPD minimum, so count, so obviously resistance is how you survived the long term. So here you are looking at rapid pace long duration and slow pace short duration, so that gives you a sense of resistance and resilience. Okay, so where was I? Yeah, global variations in recovery rate, as we said, it didn't depend on geography. Here is relative pace and count, so you can see there is a median value and the tail is relatively long. You have to understand and explain what that may mean and what the uncertainties are in these estimates. Okay, so overall durations and time to SPD minimum, so interpretations, statistical interpretations are important, but I won't go into those details. I will get quickly to the discussion because it summarizes the results nicely with words. And here again, log 10 of the rate of downturn per 1,000 years, resilience goes up as downturns go up. This is a very important relation. Similarly, resistance goes up. And here agropastoral, so land use types, agropastoralism, variability method, agriculture, and mobility. So you can see the various parameters here. This is basically about the effect sizes of model terms and dominant land use during downturns over time. So the model sensitivity studies obviously are used to say things. Dominant land use being hunter-gatherer, maritime forager, low-level food production, agropastoralism, agricultural, and mixed. Right? I hope you understand the terms. When you have lots of livestock and you are doing, basically pastoralism can mean nomadic population as opposed to agriculture, which is much more settled, which have consequences on fertility rates, population, monogamy, growth, and vulnerability to perturbations if you are moving versus if you are settled, and so on and so forth. So land use mediates resilience. The frequency of downturns over time by region was estimated by normalizing the cumulative number of downturns in a region by their duration. We transformed this to the logarithm of events per millennium to account for its strongly skewed distribution, which is what we looked at here. The variable allows us to compare the rate at which downturns occur. It consistently displays the strongest relationship to both resistance and resilience, and is the only fixed variable retained by the information criterion based selection procedure. Collectively, the results indicate that populations experience an enhanced ability to withstand disturbances as frequency increases, which is what we saw here, as well as to recover in the aftermath, which is resilience. Further examination of frequency of downturn shows that among the recorded disturbance types, changes to mobility regimes and high environmental variability occur at the highest rate per millennium, whereas cooling occurs at the lowest rate. In terms of regional variations, the highest frequency of downturns is recorded in the South African Greater Cape Floristic region, okay, and the lowest in the Korean Peninsula. So you can relate it to climate, and maybe also how that affected the diaspora out of Africa and colonization of faraway places like the Korean Peninsula. So what is the discussion? This meta-analysis has examined the potential factors influencing resistance and resilience across a broad archaeological sample and was controlled for regional variation. The frequency of downturns is the main determinant of the observed outcomes among the examined factors. The relationship between resistance and resilience displays variable rates, although these events all tend to unfold at multi-decadal to centennial timescales. Well-known historical examples support this finding. The catastrophic depopulation of indigenous groups across the Americas took place over centuries, and the collapse of imperial power in Western Rome was preceded by a long period of rural depopulation. Systematic data on dependent population downturns in prehistory are less common. However, what data are available corroborate this result. The paleodemographic downturns resolved in the radiocarbon data tend to last at least one human generation, but frequently much longer. Jumping ahead, this study finds parallels in macroecology where analogous resistance resilience outcomes have been suggested to only fully resolve at centennial timescales or above. So this has relevance for us because right now we are in the middle of climate change. We are tracking impacts with a microscope, and something gets reported every day in every corner, and some people are getting affected, of course, disproportionately, like women or vulnerable countries and poor people and so on. But if the way we are responding can only become obvious after a century, then can you just sit and watch? It's easy enough to go back and see what they did in the past, but now with the global economy, global connectivity, the social media and the information age, how do we manage the analysis of what is happening? There is, of course, human action to protect everybody and at least try to protect everybody, governments' actions to provide safety nets, infrastructure for resilience, land use protection against degradation, and so on and so forth. So it's something that is transient, and somebody will do analysis again 500 years later and look back at us and say how we responded. So these are tricky things, okay? Finally, this is the last part I'm going to read off. I don't want to read all the text, but most archaeologists work on the past resilience. Archaeological work on past resilience is historically particularistic and emphasizes the contingencies, decisions, and practices that underwrote successful adaptations in specific times and places. This specificity can be illuminating, but if historical sciences are to play any role in fostering future resilience, improving our understanding of the processes and drivers that influence long-term centennial scale resilience is a necessary prerequisite. Maybe we can look more carefully at the Holocene to make it finer, but essentially we are saying we are observing things as they are happening and we don't have a good sense of what we are doing or what our inherent abilities are in the current socio-technical setup, what our abilities are for resistance and resilience, and who is more vulnerable, right? Our approach has highlighted the global relationship between population change and frequency of disturbance over millennial timescales and applies across a broad geographical and chronological that have been overlooked in the systematic reviews of social resilience more broadly. Improved clarity on the drivers of exposure frequency and type in the past will help to reveal the mechanisms behind the dynamics we describe and their potential limits, which is particularly important as environmental variability is predicted to increase in the future. That's the climate change projections. Archaeological and historical case studies have focused on the frequency of volcanism, warfare, and hydroclimatic oscillations, as well as the rate of abrupt or extreme events in general. Comparable evidence on different categories of downturns is necessary to get the full range of impacts we are having and human responses, resistance and resilience to those. Now we also have compound events, cascading events, heat waves and droughts, earthquakes, floods and food security, disease and so on. Synthesis of these or similar data in a comparative framework can provide important insights into the causal links between population resilience, risk of exposure, and ultimately the ability to recover. So we want to take the best lessons out of these to just see, I have discussed the evolutionary baggage we carry and whether that will ever allow us to be efficient and effective in global collective action as opposed to intra-group cooperation and intra-group competition, some transient alliances that look like cooperation across groups and so on and so forth. But this is the context in terms of what are we capable of resisting and being resilient to in terms of environmental, cultural and other perturbations which are all happening together now, and what does that mean as we go into the future? Can we somehow systematize and codify these things and find the best optimal solutions for enhancing resistance and resilience? Tall order, but at least this gives you some good ideas on what to have done in the past. Okay, see you in the next topic.